We move on to our next session, which is going to be on the digital dreamer in today's VUCA world. This session is brought to you by TCG Digital. Our keynote speaker for this session is Mr. Debjyoti Gupta, CTO, TCG Digital Solutions Private Limited. Before I call him on the stage, let me take this opportunity to introduce him to all of you. Mr. Gupta has more than 2 decades of experience in offering business applications and BI analytics solutions to various sectors such as government, manufacturing, banking, and aviation. His areas of interest and specialization are ERP, controlling applications, BI analytics, and decision support systems. Leveraging the latest technology, best business practices, and delivery models, Mr. Gupta is focused on delivering the most tangible benefits to the clients. He has previously associated with Ramco Systems and Tata Steel. Ladies and gentlemen, with a round of applause, please help me welcome our keynote speaker, Mr. Debjyoti Gupta, on the stage.
Just a second, sir. আপনি ওটাকে করে দিন আমি শোতে করে নিচ্ছি একটা মাইনর এডিট আছে তাহলে আমি করে নিচ্ছি ওটাকে ভিডিও না Good afternoon, everybody. I think, thank you for this opportunity. I'd like to thank ABP and INFOCOM. And this time the theme was, I suppose, how to win in this VUCA world. So, in fact, VUCA, as the term goes, I had first mistaken it as VUCA. So, no, it was not, of course. VUCA is what we know now. This one? This one? 8. So, the first one is volatility. Rapid change, uncertainty. Of course, we do not know what's going to happen. Complexity is too many parameters, too many variables. And ambiguity is not sure whether the outcome is right, or whether it's good, whether it's bad, what is the causality. Yeah, sorry. So, typically this situation, this coin was termed, I think, in the late 80s. And this would describe the world at any point in time, of course. So it is at any time, if you throw back your mind and think, like, you would hardly come across a moment where the world was not volatile, it was not uncertain, it was not complex, it was not ambiguous. Just further looking into this thing, what we like to, put this attributes of these given times in a sort of a matrix. So on the x-axis, if you look at, it's about the knowledge of the situation. You can be well informed, you can be less informed about what is going on or how is it going to affect you. On the vertical y-axis, It's the predictability of the outcome. How sure are you that any action that you take is going to give you the results that you want? And if you just juxtapose these 4 attributes of the times on this matrix, so volatility is, you have a basically you have a knowledge of the situation and you know the outcome is also predictable. But what you do not have in your control is that when it's going to change, how fast it is going to change, and this instability. So that is the unknown that is not in your control. You talk about uncertainty. So the U part of the VUCA, this acronym, so you have the knowledge of the situation, but you cannot predict the outcomes. So that is, the future is unknown. The complexity part brings in that your knowledge of the situation is low, but predictability is high, and yet you do not have control because there are too many players, too many parameters, too many things which are engaging, and it's very difficult to keep a tab on everything and chart your path. And finally, the ambiguity is in the lowest quadrant, which you know that the knowledge of the situation is less. You know very little. You do not have all the information. And of course, you also cannot predict because these are unprecedented. Now, if you look at it in this sense, then you see that there are too many things which are going on. Business models are getting changed. You know, your customer tastes are always on the move. Your competition is always trying to cook up new things. So that gives you probably a notion that maybe the things are a little bit more complex than it used to be. At least the scale at which this complexity is, or we are getting bombarded with this complexity, is growing by the day. And to take the next steps, like, of course, you can have strategies to address VUCA, strategies in your manpower, strategies in your sales and market approach, strategies in your org structure. So we, as a part of TCG Digital, we engage with clients for digital transformation. So there are, again, like, due to our experience and how we have applied the technologies which come along with the digital transformation in the modern day, what I would like to propose or talk about very briefly is what I would say a digital dreamer's toolkit. So probably what we are going to see here is already like many of you have experienced it in many ways, in either one way or the other. But probably what would be worthwhile is maybe we can relate, like, how exactly or what is the scope of each one of them, or how they can touch your lives in facing this VUCA world. So first in the toolkit is cloud computing. So traditionally, like, computers were always on premise. You needed to invest in the hardware, you needed to invest in all the machinery, and it was let's say, an investment in the hardware, in the software, and everything. The cloud computing brings to the fore that both your hardware and software, you do not have to invest uphand straight away. They are available on demand, on rent. So if you would like to have a CRM system or something like that, you do not have to go shopping for software. You do not have to go shopping for the hardware to put it. You do not have to even get in software developers to make that software. In fact, this CRM application will be available on the cloud. All you need to do is the registration. And you need to just probably keep on providing a rent for using the software. So rent for using the software, getting the functionality, meaning whatever value your business is going to get from it, this entire model has been changed from capex to opex. So you can straight away straight away put it to your profit and loss, and you can see that if it is your monthly expenditure that way, The benefit that you are getting from using this software is this much. And you have a choice to stop using it. You have a choice to change the software. You have a choice to go to another vendor, provider. So that actually gives a lot of freedom. That gives a freedom. So what does it address? You know, this volatility that you're facing, your situations are changing. Suddenly you need to have a new tool to address this volatility. You have a very easy choice to walk into a shop and then just start using a tool which is readily available, bringing down the cycle times. Like earlier on, it would be probably 3 to 6 month, a cycle time to roll out that software and train the thing. But now it can be brought down to just around a couple of weeks, and that is it. You are up and ready to go and start using, getting the benefit. So that is something about cloud computing. The second one, which is actually very, very, I would say it is all pervasive these days, is the Internet of Things. Probably in our daily lives, we find, the touch point with them not so often, except unless you treat your smartphone as an Internet of Things. Of course, it keeps you guiding along which roads you're going, what's the traffic you're going to face at the next signal, how long you're going to take. So that's one example. But the Internet of Things is about devices and sensors which are continuously sensing the environment and transmitting these messages, transmitting these signals into a cloud-based. Again, we are relying on the cloud to do it, in a cloud-based environment where these signals can be acted upon. There can be sophisticated software which could interpret these signals and which could take steps. So we are talking about smart cities. Ideally, let's say a very simple example is the traffic signals. They are timing on their own. They are changing the times on their own based on the traffic flows by the different roads which are coming into that signal. And this is happening, there is no human intervention. So the cars that are moving in are being sensed. The flow of the traffic is being sensed. And based on certain algorithms which is sitting on the cloud, the timing for this signal is changing. So if there is a traffic, like evening times, there's a huge traffic down the Eastern Metropolitan Bypass, which is moving from Salt Lake to probably the south side, and in the morning it's the reverse. The signal could detect that traffic on its own, and it could give a longer wait time, or it could give a shorter wait time. It could have more open pathways for the traffic to move in from the north to south on Eastern Metropolitan Bypass. So that's an Internet of Things. That's a smart city. The smart cities, you talk about smart buildings where lights get switched off automatically if there are no people in the hall or the room, and you're saving energy that way. You have smart agriculture now. So drones or satellites taking a snapshot of your field, of your cultivable land, and based on the pictures interpreting the state at which your crop is, whether your crop is showing a healthy growth or it is not, and are there any interventions which are required, automatically triggering that, okay, there are certain insecticides that need to be sprayed. Same thing, smart manufacturing, smart personal health. So smart personal health is something that like we all are, probably several of us in this room are having that. It starts with a Fitbit on your arm, which actually monitors your heartbeat, your blood pressure, your sleep patterns, and advises interventions. So there's an Internet of Things. What's happening is there is an all-pervasive device which is actually it's all around us and sensing the signals and trying to make life easier for us. The third thing that we work with is artificial intelligence. And this again, it starts with your smartphone. It can hear you talk. You can talk to it and ask it to ask certain directions, and it will automatically throw you a map and guide you and navigate. So that's one part of it. But AI is almost everywhere today. AI is there in the way the airlines are actually, pricing their tickets, the way the logistics companies are promising when you are going to get your goods delivered in time. So it is almost everywhere. But the most interesting thing is, like, if you really start giving a thought or look at how AI is touching your lives, you will never stop getting surprised every now and often, but there is always a new use which is coming up, and that's very significant in our lives. And when we say that, when we are facing volatility, uncertainty, and complexity, and ambiguity, and all these things, now AI is probably something, is a very, very powerful tool which can go a long way in making you stronger in face of this. The last one that I would like to mention is probably it's not so visible now, and now in your current in the present times, but it's very soon, like it is gaining a lot of usage. It's a lot of traction in the market, and very soon we can expect to see this in a very widespread usage across all fields of activities. And this is blockchain. Now, blockchain as a technology, it is just a way of organizing records and files. So today, I think almost all of us are conversant with database systems. So your railway reservations, your airline reservations. In fact, even if you go to a store and the storekeeper draws up when the point of sale operator, he keeps on scanning your merchandise, and automatically the prices come, the discounts come up. They are all accessing a filing system, which is usually a database management system. But what is particular about these present day systems are these filing systems are all in one place. They are in one computer. The store's data is in the store's computer. The railway reservation data is in a centralized computer with the CRIS data center. And the data is organized there. So what is going to, this blockchain is going to enable is these databases can be distributed, meaning they can be freely floated around. So what that gives is, this gives an enormous possibility of scaling, meaning a store's database can handle only that many number of merchandise, only that many number of customers if they are coming in. If there is more merchandise or a more number of customers, what the database needs to do is it needs to scale up. You need to buy some bigger hardware, put it there, or upgrade your system and things like that. But this distributed database system, what it allows is, as and when the business grows or the transaction grows, the database can be spread on many such computers, in a cluster of computers, all of them on the cloud, and there's virtually no limits to it. The thing which comes up, which the significant factor which comes up, or the question that comes to the mind when you're distributing your databases around, is how do you ensure the security of your data? Meaning, if you were to push your transaction records in 5 or 10 different computer nodes across the internet, how do you know that your competitor is not able to look into those databases and read your transaction and find out how much volume of business that you're doing? Now, that is the tricky part of this blockchain. So the blockchain system is a self-governing, is a self-encrypted system on its own. So it is almost next to impossible to hack into a blockchain system and to decipher the data unless you have the right keys, the cipher keys for doing that, and which is what your application ensures. So what has happened is, by actually ensuring that there is a sort of a safe locker, you have the freedom of distributing that locker of data across anywhere. You don't need to carry the burden that has to be my premises. It can be anywhere, and I can make another locker where the data can go. And the keys to the locks are there with your application. No one can pilfer that. No one can hack that in. And that gives a big freedom. Like, if you just think back on it, that gives a huge freedom for you to not having to bother about right at the beginning, oh, my business is at this percent, but if it grows for 200, 300% the next year, what do I have to do? Do I have to buy new database and do that? The architecture will support. But this blockchain system is something that it allows doing it without the fear of being hacked or without the fear of losing and pilferage. Now, with these tools, just going a bit deeper, I'll just glance over this. So this is a schematic of cloud computing. So what you have is, on the cloud, you have the application, you have the infrastructure first, so you can ask for servers, basically computing power, which is processors. You can ask for storage, you can ask various different kinds of storage. You can ask for relational database storage, you can ask for a blockchain storage, you can ask for an amorphous, unstructured sort of a storage where you like to keep your website data, the blogs and stuff like that. So that is the infrastructure part of it. And then come the applications. Riding on these infrastructures, there's a whole host of applications. So if you look into the marketplaces of Amazon, that is a very popular cloud service provider, that AWS, Amazon Web Services, or Azure on the cloud, you get to see a whole host of applications. And not only applications, not only end user applications, you have application development tools on hire, available on rent on the cloud. So this, and finally, you access all these things through any kind of devices. So your smartphones, your computer, desktop computers, tablets, anything can get you to access these resources on the web. The Internet of Things is, we just described, there's a whole set of devices which are actually going through in a secure manner, recording the transactions. Coming to artificial intelligence has many flavors, and this is one look at the flavor of the thing. One part of the artificial intelligence which are very much in use, and almost all businesses are making use of it, is in machine learning, based on the past historical data. Can the machine test? Or past historical data, how can I predict the future? So there's a lot of predictability that you can bring in reading your data and interpreting it, and training your applications to learn from the data, to detect patterns, and advise you on the steps that need to be taken. In many cases, it can even take the steps on its own, that is automating the AI to execute application workflows. The second avatar of artificial intelligence is when you talk to your smartphone. When you ask Google, show me the direction from ITC Sonar to airport. And there is a Google Assistant. If you talk to, if you are using iPhone, you have a Siri there. If you're using Amazon devices, Fire Stick or something, you can ask Alexa to play you a song. Now, this is actually, speech recognition, and your spoken human language is interpreted or being understood by the computer. And for several, it has a huge amount of the speech recognition and natural language processing has a huge amount of application. You get to see chatbots on several websites. Some of the chatbots allowed you to speak to them. Some of the chatbots, you got to type your query. So if you go to a chatbot, let's say a HDFC Bank, and type a query that, how do I get a home loan? So the chatbot automatically will interpret your simple natural language question and take you to the HDFC home loan page site, where you can, again, where you will be able to see like what are the processes and what you need to put up for this. This actually, it removes a lot of human interface from that, and it allows the systems to scale. So you don't need to put a call center or a receptionist behind a phone to answer your call, receive your call, and answer your query. And it's a computer which can do that, and computer has access to the relevant information and can deliver you that information on its own. Of course, there is we hear of artificial vision, that is image recognition. All of you who have been in Facebook, or you have accounts in Facebook, you can try this looking, and sometimes even I get surprised when I am tagged in a very old picture, maybe 20-30 years back, and that picture, the Facebook could recognize my face and tag my name with it. Now that is an image recognition, and in real-time image recognition, you can see with autonomous vehicles that they can automatically detect that in front the road is turning, or there is a person who's walking on the road, and take the necessary action. So there are various ways that AI touches our lives, and these are just a few of them. So I just dwelt on the blockchain part of it, and this is just a schematic for a distributed ledger. So in a central bank, so instead of a single centralized ledger, what I had described is distribute this database into several nodes, and that is a distributed ledger. So looking back at how we address VUCA, so for volatility, to counter volatility, what you need is agility. You need to agile. If change is given certain, you need to be quick to change. And if you look at that, cloud allows you that agility. You can quickly scale up your systems. IoT allows you that agility. The sensors allow you to scale up. So whenever you're talking about the agility, these things allow you. The uncertainty is you need to be predictable. So where you apply artificial intelligence to a good measure. The complexity part of it is you have to take care of many variables. So you have to provide for a huge scaling of machines, of distributability of compute power. And in fact, all the 4 members of this toolkit, they help you do that. And finally, with blockchain, you can foster automation. So in managing convergence, basically what we do with TCG Digital and digital transformation is we manage the convergence of all these 4 elements. So if you can do that well, your VUCA can take a different look. So it would be vision, understanding, clarity, and action in face of what you have for VUCA as represented in the earlier picture. Thank you very much for your time.